So this one is basically convection, heat transfer, convection mode, atau convective heat transfer. Okay. So you have introduction, the thermal boundary layer, the internal and external force convection, and you have heat flow through tube wall from one fluid to another. Okay, which is related to heat exchanger sebenarnya. Okay, jangan risau yang ini tak ada indication apa-apa yang cakap ni ke apa, ada unsur-unsur 18 ke apa, tak ada sebab kalau you tengok balik pada this gambar ni, dia kat tepi pantai kan. Okay, sebenarnya orang ni yang dia pakai ni sebenarnya adalah apron jangan salah anggap sebab tengok badan dia kan kurus dia. Dia pakai apron yang badan tough tu. So nampak badan dia macam tough lah. So basically dia nak tunjuk about where and how, okay, heat transfer happen, kan? So dekat sini memang everything pun adalah heat transfer. Tengok sampai panas sampai dekat apa? Dekat atas boot kereta ni pun boleh ni boleh masak daging dan sebagainya, kan? Walaupun tak safe lah sebenarnya. Ni ada aluminium foil, okay, heat transfer. Yang ni pun grill ni pun heat transfer. Asap heat transfer. Bahang adalah heat transfer. Ni aiskrim cair pun daripada matahari ni heat transfer. Yang ni kesian, aiskrim dia jatuh Yang ni dia pakai kipas angin, okay, convection, convective heat transfer, okay, dan sebagainya lah. Okay, even yang sayur hijau ni pun is heat transfer. Okay, dan juga buah ni sebab dia ada radiation. Sebab the temperature above absolute zero akan ada radiation. So vegetation is a part of high emissivity punya substance atau material lah yang ada high radiation, high emission, okay, emissivity yang tinggi, okay. So dia dapat high heat juga, radiation daripada sun. So this is all the phenomena of heat transfer. Okay. So now we are talking specifically on the asap itself, which is convection. Okay, heat transfer. So convection is mechanism of heat transfer through a fluid in presence of bulk fluid motion. Okay. The keyword for convection is a fluid motion. Okay. So for this kind of heat transfer mechanism, okay, it is rather different compared to the conduction, okay, because it involves bulk fluid motion. So when it involves bulk fluid motion, you have to know two things, okay. Number one, fluid properties. Okay. Number two, fluid flow, which involve region lah. Okay, region ataupun regime. Okay, so region ni will refer to whether it is developing atau fully developed. Developing ni dia masih lagi belum stable lah. Fully developed ni dia dah memang dah lengkap prosesnya ataupun dari steady state. Regime, flow regime basically will be determined based on RE lah. Okay, which I think you're familiar with RE, right? Knox number, okay? So for basically convection is about to determine the value of H, okay? And what might be the relationship of H and K, okay? K is reflect to the material. H is reflect to the geometry. Okay, geometry and the fluid flow lah. Okay, so dalam ni kita akan ada internal, external. Nanti kita tengok lah. Okay. So consider heat transfer in figure 1. Okay. Ada heat transfer. No fluid motion. It will strictly conduction from heat or from hot plate. Okay. It will transfer down to the fluid. Then based on the molecule reside in the fluid, it will also be contacted each other, colliding each other. Okay, and then it become higher in temperature from one side to another up until when it reach cold plate. Okay, then cold plate is also will be heated lah as a result of the hot plate tadi. Okay, and if you have motion in the fluid, okay, it will enhance the heat transfer. So the cold plate will become much more hotter, um, a little bit faster, okay, because of the effect of the convection. Okay, so it is speed up the heat transfer process. Okay, so um, liquid motion. Okay, if the fluid is liquid, it will be much more um, easier to be heated, okay, ataupun to be transferred in terms of the heat, okay, compared to gas lah, sebab gas ni lagi jauh kan jarak dia, so basically dia lebih in terms of heat transfer, liquid is much more better lah, okay, the heat transfer process. Okay, right. Okay, if you reflect back to the previous slide or the previous topic, which is conduction, it will only involve several factors that will influence the rate of heat conduction. Ada 4 je kan. So for heat convection, okay, so this is can be regarded as the most complex heat transfer mechanism. Okay, convection is the most complex heat transfer mechanism because of H value tadi. Because of ni. Ini je sebenarnya isu dia. Okay, H. So because H will determined by fluid flow, okay, determined by the roughness of the surface, okay, and will also determined by the geometry of the surface, whether it is internal or external, or whether it is in the cylinder ataupun in the sphere ataupun in annulus and so on and so forth. And you have also fluid velocity V, and specific heat Cp. Then you also have density rho, and you have thermal conductivity K, and you have dynamic viscosity, which is this one. Okay. Dia macam V, okay, tapi dia bukan V, dia nama dia NU. NU ni sebut apa? Kalau NU, macam mana U ni? Yang ni huruf Greek letter Greek letter. This would be the dynamic viscosity. So dynamic viscosity is basically mu over rho. Okay, mu over rho. Okay. That is dynamic viscosity. So that is the factors that will affect the rate of heat convection. Okay. All right. We go to the specific theory on the convection. Ada dalam 10 minit lagi ni. We call it Newton's law of cooling. Okay. Dekat dalam conduction, we have Fourier's law of heat conduction. And then for convection, we have Newton's law of cooling. Okay. The general equation for convection is this one. Okay. And this one is the flux, heat flux. Okay. Whereby you have over A lah, Q, the convection over A. Okay. So just like what have been mentioned to you in the previous chapter, the equation is Q is equals to HA delta T. So this one is surface temperature and the surrounding temperature. Okay, and AS is the area of the surface and H is the convection heat transfer coefficient or convective heat transfer coefficient. Okay, so at the solid surface, okay, at the solid surface, kat surface ni yang plate ni, okay, dekat surface dia, dia punya velocity is equals to 0. Okay, and the profile tu jadi macam ni lah. Okay, maknanya makin ke bawah ni dia akan ada effect of viscous dia panggil. Okay, yang mana that particular condition we call it as no slip condition. Okay, so bila no slip condition, fluid in motion comes to a complete stop at the surface that is non-porous. Okay, because kalau ada kalau ada porous problem lah, okay, dia akan slip ke bawah kan dan sebagainya kan. So we can assume this as non-porous lah. It is assumed that zero velocity relative to the surface. There is a fluid in direct contact with solid sticks to the surface due to viscous effects, and there is no slip. So no slip condition ni is basically to tell you that at the surface ni dia punya velocity is equals to 0, okay, due to the viscous effect as a result of the surface ni tadi. Okay, and then this is when Q convection sama dengan Q conduction dekat no slip condition. Okay, so daripada this relationship kita akan tahu apa relationship in between H dengan A. Okay, sebab kita memang perlu tahu hubungan antara H dan K sebab in the end kita kena cari H. Because H is not the property of a material. H will depend on the fluid flow, the velocity of the fluid. Okay, so what is the relationship in between velocity and the thermal system is being explained or being expressed by the relationship in between H dan K ni. Okay, so akhirnya berlakulah this introduction of the theory lah, which is being called Nusselt number. Okay, by this pakcik. Okay, Wilhelm Nusselt nama dia. Okay, which is he introduced the Nusselt number, which relates in between H and K with the characteristic length lah. Okay, this characteristic length ni is basically the mewakili panjang surface tersebut lah. Okay, and then the thermal conductivity and the heat convection. Okay, so maksudnya kat sini, if Nu is larger value, okay, more effective convection. Okay, maksudnya sekarang kalau Nu is very high, okay, let's say Nu is 100, okay, so bermaksud, okay, nu ni ataupun HL ni, motion Yang K ni is conduction. So ni motion atau convection lah. Okay. So conduction akan 100 kali lebih kecil daripada convection. Okay. Bila larger value of nu ni. Nu pula, nu ni. Okay, nasihat number ni nu lah kita sebut. Okay. Kalau dia sama, okay, bermaksud pure conduction atau no slip condition. Okay. Maksudnya conduction, convection sama dengan conduction. Okay. No slip condition lah tu. Okay. Kalau value apa conduction tu, kalau value ni kecil, okay, lebih kecil daripada 1, 0.0 something, that signify that the conduction is dominating the process. Okay, so normally this will be related to the value of K lah. So that is why metal then the high conductivity material ni is normally lower value of Nusselt number. Okay. Compared to ni lah, to the convection. So dia lebih dominate lah. So in this chapter, you will have to learn on the ni lah, several terms lah. Okay, viscous versus inviscid regions, internal versus external flow, compressible versus incompressible flow, okay, laminar versus turbulent flow, natural versus or free versus forced convection or flow, steady versus unsteady flow. So normally we will only consider on this steady flow. Okay, ni tak ada lah. And 1, 2, 3 dimension ni tak ada. Ni tak ada, ni tak ada, yang ini je ada. One dimension. Okay. Natural we will not ni. Boleh lah, ada jugalah natural. Sikit. Force convection pun ada. Okay. Normally dekat dalam yang ini dekat dalam pipe. Okay. Yang ini environment. Okay. So laminar and turbulent memang ada lah dua-dua. Compressible, incompressible ni pun ada juga dua-dua. Internal and external, yes. Viscous and inviscid ni pun ada. Okay. So this is the classification lah yang you perlu tahu.